Hello everyone, welcome back to Algo Daily. In this particular video, we are discussing LeetCode daily challenge, and this is a hard level problem. And the problem is divide nodes into the maximum number of groups. And first, we have to given a positive integer of n, which represent the number of nodes in a undirected graph. The nodes are labeled from 1 to n, and you are also given a 2D integer array edges, where edges of I is equal to a of I, and which indicates that there is a bidirectional edges between AI and BI nodes. And we have to notice that given graph may be disconnected. And now we have to divide the nodes of the group into m groups, and which is one index, and we have to given a two conditions here, and then we have to return maximum number of groups of maximum of m into which you can divide the nodes. And if this one is not satisfied, and then we have to return -1 if impossible to make the group and the given nodes and the given conditions. And now let's look at their problem statement. Then we have to look their example test cases. Then we have to uh, go with their problem sample code. And here first we have to given a undirected graph, and this undirected graph which we have there n nodes, and which is labeled from 1 to n. Okay, this 1 to n, and we have also have a list of edges where each edge is a of I comma b of I. Okay, and we have to represent a bidirectional connection between a of I comma b of I. And our goal is we need to partition the nodes into the maximum number of groups, which is denoted to m, and each group and you can say each node belongs to exactly one group. And the second one, we have to given a edges between two nodes a of I comma b of I, and this ai is x and bi is y, and you must have a group with x plus 1 comma x minus 1. Okay, you have to you have to take, not take, you have these are the condition, you can say. And now we have to return the maximum number of groups if possible, max number of groups possible, and if it is not possible, then we have to return -1, like there is no valid grouping is possible. And now let's look at their constraint. The constraint are 1 less than is equal to n less than is equal to 500. So here we have the moderate size we have to given. So we have to compute the algorithm with O of n square solution and O of n log n solution, and both are working on this constraint. And the same thing we have there 1 less than is equal to edges dot length less than is equal to 10 to the power 4. So here we have to create a sparse graph. This sparse graph is not a fully connected graph. Okay, and the same here we have 1 less than is equal to a of I and b of I, and this a of I and b of I is our a and this a of I is not is equal to b of I. So here no self loops are allowed, and here this one is at most one edge between any pair of nodes, no duplicate edges are present. So now I hope you understand what actually we have to want, and the constraint for which algo we have to use, O of n square or O of n log n solution. It may work on that problem. So now let's look at their problem statement. We have to also discuss here, and then now let's look at their example test cases. So first we have to given this group 1, group 2, group 3 and group 4, and these are our colors. Here green, here blue, here violet, here you can say orange, and these are our colors, and with their inside this we have to given their nodes. And this is n is equal to 6, and we have to given the edges 1 2 1 4 1 5 2 6 2 3 and 4 6. And the graph representation of this one is, first we have there, let's suppose we have to take this 5. Okay, so this 5, sorry, this one, and this one is connected with 2 and 4, 2 and 4, and also connected with 5. Okay, and then this 2 is connected to 3 and 6, 3 and 6, and this 5 is not connected to anyone, and this 4 is connected with also be 6. You can say here is 4 and here is 5. Okay, and this 6, and this is the representation of this one. Okay, so I hope you understand how actually we have to build a tree form. Like here is 1, this is our source, let's suppose, and this is the second level, and this is the third level. And now we have their group 1, and this is our group 1, G1, G2 and G3, and this is G4. Okay, and this group 1, the value is 5, group 2 is value of 1, and group 3 is value of 2 comma 4, and the group 4 is 3 comma 6. And the valid group of AI comma BI has the group of I, like the valid edge of AI comma BI is equal to the absolute difference of and AI comma BI. This is the group AI comma group BI, and we have to find their absolute difference is equal to 1. And the maximum groups we can calculate here. So how we can achieve the values from the both connected components basically. Okay, so here first one is connected with, this one is connected with 2 4 and 5. Okay, and this 2 is connected with 3 and 6, and once again this 2 is connected with okay, this is the undirected graph, so we have to track with this one. Okay, this 2 is connected with 1 3 and 6, and this 4 is connected with 1 and 6, and this 3 is connected with 2, and this 6 is connected with 2 and 4, and this 5 is connected with only 1. Okay, and now we have to divide this dividing graph into groups. So here dividing graphs into groups, and now we need to divide the nodes into a group such that each connected components belong their adjacent edges. So the group one is start with the node, this node, this 5 node, and this 5 it is isolated because it is connected with only one. And this group 2 we have this add a node with this one is 5 to 1. Okay, 5 to 1, so add node 1 and the connected with 5. And now just group 3, this group 3 is connected with 2 and 3 here, and we have to add nodes 2 and 4. Okay, 2 and 4, and width is connected with, this is connected with 1, and the group 4 is here 3 and 6, which is connected with 2 comma 4. 3 and 6, 3 is connected with 2 and also here, and 4 is connected with 6 here. Okay, so I hope you understand. We have to divide, how we divide the edges to their graph representation. And now the edges, all the edges are uh, 1 is 2, 4 and 5. Okay, 1 is connected with 2, 4 and 5, and 2 is connected with 1, 3 and 6, and the 4 is connected with 1 comma 6. So now here we have to calculate their differences, and to find their values, how we get all the values, and we have to find their uh, check with their conditions, like, okay. So first, the difference between we have also calculating their difference, okay, which satisfy the condition. And now this 2, 4, 5, which is the group of 2, 4 and this 5, which is the group of 2, 3, this 2, 3 and 1. Like here we have to connect with this one. You can also check this one connected with 2, connected with 3. Okay, so this 2, 4, 5 is connected with 2, 3, 1, and the same thing we have their group uh, group of 1, 3 and 1, 3 and 6. This 1, 1, 3 and 6 is connected with 2, 3 and 4. Okay, because we have to go through with this condition, this condition, this condition, and so on. So you can say the group is 2, 3 and 4. And now, and 1 and 6, this 1 and 6 is connected with, you can say 2, 3 and 4 is also we have to reach this position. And the same thing we have to here, 3, 2, 4. And now we have to final maximum of this one, like we have also discussed here, the return the maximum number of groups, which is the maximum of m. So here the maximum of m is equal to 4. Like both the cases we have to get their maximum value. And you can also find the absolute of ai comma bi, and like you can say this this one difference we cannot we can calculate, here we have to calculate, here we have to calculate, but we have to find the maximum of all these connected components. Okay, and now let's discuss their example too, so that you have to understand how actually we have to work. And this one input is, one second, and so here, and here first we have 3, and their edges is 1, 2, 2, 3, 1, 2, 2, 3 and 3, 1. Okay, and this is number of nodes. And this one is connected with, how actually it look like, this one is connected with 3, and this this 2, and this 2 is connected with this 3. Okay, and this one is connected with this one. Okay, so we have to create this type of tree structure, you can say, and graph structure, and the we have to checking with all the group nodes. And so first we have to assign 1 with group 1 and assign 2 with group is 1 minus 2, and edges are satisfied because absolute difference of this one is 1, and assign 3 is, this 3 is group of 2 minus 3. Okay, group of 2 minus 3, and this one is also be satisfied because absolute difference of 2 minus 3 is 1. And but now this 3 is the connected with 1, and it must be a group of 2. Okay, because this one is also be a group, and so this 3 is connected with also be 1, and which is must be a group of 2. Both groups, like 1 3 is connected with 1 and 2, and so but it is a group of 1, but we have to connect it with also be a 2, but this is not a condition satisfied because absolute difference of 3 minus 1 is 2, and the absolute difference of 3 minus 2 is 1, but we have to get absolute difference of ai comma bi is equal to 1. So it is the condition we have to not achieve on that particular part, so that's why we have to return -1. So I hope you understand. First we have to in first example we have to calculate with their pairs, and we have to find their pairs and their values, and then we have to directly return their maximum. And here what we have to do, we have to find their absolute difference. We have to check with all both like we have also discussing the maximum pairs we have to first we have to build, and the second example we have to get our answer by using absolute of ai minus absolute of ai minus bi solution. So I hope you understand how actually we have to find their values and find their maximum values basically. And now let's look at their coding implementation part. So here first we have their color, and this color is stored the bipartite coloring of 0 comma 1, and this widget is track the nodes from -1 to, we have to check with their nodes, with their unvisited nodes, and this check stored the nodes in current connected component, and this vector of vector int of adjacent and distance, and this adjacency is the list of graph representation, and this distance is stored the shortest distance between nodes, and this shortest distance means absolute of ai comma bi. And now first we have to create a BFS function, and this BFS is for a component starting from their nodes of I, and now we have to mark as visited of 0 starting, and here we have to process this while loop. We have to process each node from the queue. Here we have each node from the queue, and then we have to store with f and check, we have to tracking with their components. And now this for loop is actually their adjacent node. We have to calculate if it is already visited, then if it is already visited, then its color is not the opposite, then we have to return the false. Okay, then we have to return the false, like we have to detect odd cycle detected. One scenario you have to look here, if there is 1 2 3 4, and this 4 is connected with 1, but here we have to calculate their absolute difference of 2 minus 1 is 1, 3 minus 1 is 1, and 4 minus 1 is 1, but here we have to connect it with this one 4 to 1, and this 4 to 1 is absolute difference is 3, so that we cannot get our answer. So then we have to return -1, because we have to find ai minus bi is equal to 1. Okay, so here we have to detect our cycle, and after that, otherwise we have to, here we have to assign the opposite color, and then we have to return true. And same thing we have for this BFS for maximum distance. Okay, and this BFS we have to calculate the bipartite graph, and here we have to calculate the maximum distance, and we have to calculate first the first we have their distance of I is equal to 1. It means there is a self distance, and then we have their q, and we have to store all the values, and we have to find their maximum. Here we have their condition, and then we have calculate all values, uh, and then now we have to jump in main function. This is our main function, and first we have initialize their adjacency list and matrix, and then we have their build the adjacency list, and then we have their mark all node as unvisited. Okay, and then we have to check their bipartite. Okay, and then here we have their run our BFS. For each node we have to calculate their distance. Okay, distance we have to calculate here, and now this uh, answer and this for loop, we have their unvisited node, we have to check their calculate their distances, and now here we have uh, these for loops, and we have to check their conditions. So basically this one is generally for unvisited nodes and check bipartite, and they find the largest and longest distance their component, and then we have to check their we have to clear this one, and then we have to add their answer. Okay, and after that we have their here if check is equal to 0, then we have to return -1, and the same thing we have to calculate here, like we have to check with their visit or not visit, and then we have to return directly minus answer. So basically you have to determine first bipartite graph, and then with their maximum distance, and then this is the iteration based code for the main function. Okay, so now let's discuss their test cases, so that you can understand how actually we have to compute all the values. And so first we have their construction. So first we have to create a graph, and this graph is we have to process O of m time, and the BFS of bipartite, and we have to perform the BFS of bipartite, and this takes O of n plus m time, and after that we have to find their shortest distance, and we have each distance we have to calculate with their values, and we have to take O of m time. Here we have BFS of max, and this is O of n plus m time, and this O of n plus m time, and then we have also run into n time, so into n time. Okay, and then the last we have to find their distance with their components, and so we have to max pairwise shortest distance we have to calculate. So this one is O of k square time. Okay, here, and then in worst case k is equal to 1, and sorry, and so that O of n square for single component. Okay, and this is the whole component, and this is the single component, and then this is, and the we have their bipartite graph, and the bipartite graph of check with O of n plus m time, and the total time complexity of this code is O of n into n plus m plus O of n square is equal to O of n square plus n into m, and this is our time complexity. But one thing is, if the graph is dense, then this m is equal to O of n square, and so that this will become O of n cube. Okay, this will become n O of n cube, and the graph is sparse, then m is equal to O of n, and so that this will become O of n square. So sparse and dense graph, we have to differ our time complexity. And now the space complexity of this code is the adjacency list. This adjacency list is O of n plus m, and the widget array, and we have also compute with their check, color, and so on. So this takes O of n time, and the distance matrix we have also built here, O of n square, and the q is our O of n time. So the total space complexity of this code is O of n square plus n plus m. So the total is O of n square. So I hope you understand the logic and the implementation part of this code, and their time complexity and their space complexity. So it is a little bit trickier part for how we calculate with their pairs and their absolute difference. So thank you everyone. Thank you so much.